section different than what the book does. So if you were doing this section, make sure that you are following what we're doing today in the notes, because it is not like the book. So show means write a 2-column proof. Okay? They give you measure of angle 3 equals 2x plus 15. Measure of angle 5 equals 3x plus 15. And x is equal to 30. So this is given. And again, they didn't really say prove, they said show what that means to write a proof. Okay, so we started where when we wrote one like this in class? What do? Okay, we write down the given. So we start with the 2-column, statements and reasons. If you're watching the video, I'm doing this on the whiteboard. So listen carefully because I'm going to state exactly what I'm writing even though you can't see it. So first statement is going to be the given. If you're looking in the book, that's measure of angle 3 equals 2x plus 15. Measure of angle 5 equals 3x plus 15, and x equals 30. And so the reason for number 1 is given. And again, this is one of your homework problems, so make sure you're doing this with us. Okay, and what did we do last class period after we wrote the given like this? We substituted. So statement number 2, we're going to plug this 30 in where the x's are. So we're going to have measure angle 3 equals 2 times 30 plus 15, and measure angle 5 equals 3 times 30 plus 15. And the reason is what again? Substitution, property of equality. Now this may not be as quick for you if you haven't done any of the problems like this like we did in class. If you only did section 3.2 and you didn't do 3.3 at all, then you're going to have to look back at your notes. We did one like this in the notes, except it was a little bit different. Okay, what do we do after we substitute in the 30? Is it distributive property? It's just simplified. Distributive would be if all of this was in parentheses and we were going to both, right? But we're just simplifying one side of the equation over here. So statement number 3 is going to be measure angle 3 equals, good, 2 times 30 is 60 plus 15 is 75 degrees. And then measure of angle 5, we're going to have 3 times 30, which is 90 plus 15, 105. And what was my reason again? Simplify. Okay, notice that they are not equal to each other. Last class period, the problem that we did, we had 2 angles that were equal to each other. So it was different, but look at angles 3 and 5. What kind of angles are 3 and 5? Same side interior, and so we don't want our same side interior angles to be supplementary in order to, equal in order to prove the lines parallel. We want 3 and 5 to be supplementary in order to prove the lines parallel, right? So if we look at 75 and 105, do those add to be 180? Okay, we have to show that, and this is something that we haven't ever done in a proof before, so I wanted to do this with you to show you what your next step would be. What we're going to do, and we've actually seen it done, but we haven't actually written it ourselves. But we've looked at proofs where we had to write this as a reason. So if I take this equation, measure of angle 3 equals 75, and I add angle 5 to the left side, so I'm going to have measure angle 3 plus measure of angle 5 equals, so I'm adding angle 5 to the left side, but 5 is the same as 105. So instead of adding angle 5 to the right side, I'm going to add it as 105. So I added 5 to the left and 105 to the right. Do you agree that the measure of angle 5 and 105 are really the same value? And so what I'm adding to the left and adding to the right is really the same amount. Agreed? So what do we call it when we add something to both sides of the equation? Addition property. So what we're going to do is use the addition property of equality. Questions? Stop me if I'm losing you. On the left, I added the measure of angle 5. Let me write it a little neater. No, it's okay. I couldn't get in there. Measure of angle 3 plus measure angle 5. So I added angle 5 to the left. And since 5 is the same as 105, I added 105 to the right. And even though it looks like I added different things to the left and the right, I actually added the same value, so it still keeps the equation balanced. We didn't add something different. Does that make sense? Okay, so that's kind of new. We haven't done that before. We've seen it done, but we haven't actually written it. What do we do next here? We need to simplify. We need to go ahead and add 75 plus 105. So number 5, I'm going to come up here since it's hard for you guys in the back to see way down there. So number 5, measure of angle 3 plus measure of angle 5 is actually equal to what now? 180. And we did what? Simplified. Can you guys see that? Now I have that 3 and 5 add to be 180. What do I want 3 and 5 to do so that I can prove the lines are parallel? Okay, we want them to add to equal at 180, but I think the theorem actually says if same side interior angles are what? Supplementary. And we have them added to equal 180, so we need to add in one more step that says angle 3 and angle 5 are what? Okay, are supplementary. And why, Raina? What's the reason? Definition of supplementary. If they add to be 180, then they are supplementary. That is our definition of supplementary. Are you allowed to abbreviate? No, I'm going to do a bad example and abbreviate since these are our notes. But don't abbreviate on your actual homework. Okay, so now we have 3 and 5 are supplementary, and if 3 and 5 are supplementary, what does that tell us about lines N and P? They are parallel. So number 7, N is parallel to P. And then what is the only reasons we've learned to prove lines parallel? What do they always start with? Converse of. Remember, we had 5 postulates or theorems about these angles. And we said last class period that if the angles had those requirements, either congruent or supplementary, then the lines would be parallel. And all we did is switch the hypothesis and the conclusion. So number 7 should be converse of, and then what kind of angles are they? Same side interior. So this is converse of same side interior angles theorem. So the extra things we had to do a little different, we had to use that addition property where we basically added these two sides and these two sides together. And then we had to simplify that down, and then remember that adding to 180 is the same as being supplementary. Questions? Okay, I want to do one more proof off of 3.3 in your notes, but I'm not going to do both of the proofs. So just one more proof. If you'll look with me, I'm going to go all the way to, let's do this one. So find example 3. Is this the next one in your notes? Okay, so we're going to do this one. We're not going to do the last one. And then we'll move on to 3.4. So statements, I should have given you a statements and reasons box to the right. And the very first thing we always start with is the given. So I'm going to write just one part of my given first. P is parallel to R. Given. And then I want to remind you that you should draw the picture if you need to mark on it. You should not be marking on the pictures in your textbook. You did not buy that book. It is school property. You shouldn't be writing in your textbook. That's defacing school property. If you've been doing that, erase your marks. Start drawing your pictures, okay? So Look at the picture. Did they mark P parallel to R? No, they made a mistake. This should not be marked parallel. That's a typo. P should be parallel to R. That should have been marked. So fix that. Those parallel marks should not have been there for lines L and M. That's our goal. We want to prove L parallel to M. So we don't ever mark what we're trying to prove, only what's been given. Okay, so now I want you to think about what we learned last class period. If P is parallel to R, what do we now know? Look at the picture. Look what's been marked in the picture. If P is parallel to R, what's something that we know? Okay, I hear alternate exterior. What was I hearing back here? Okay, do we know that 1, 2, and 3 are all the same just from P and R being parallel? Just from this. One's not made by transversal M, one is made by transversal L. So right now it doesn't have a relationship with angle 3, only with 2. And we don't know that these are parallel, so we don't know that 1 and 2 are congruent. Okay. We do know that 2 and 3, if I'm using just these two lines and this transversal, that 2 and 3 are alternate exterior, and therefore if the lines are parallel, they are congruent. Okay? So we could say step number 2, angle 2 is congruent to angle 3. And what's going to be the reason? Very good. Alternate exterior angles what? Theorem. Don't make that harder than it is. Just look at the picture. What kind of angles are they? That's the name of the theorem. Alternate exterior angles theorem. Why didn't we say converse of? Okay, we already know the lines are parallel. We're not proving the lines parallel, and the only time we use converse is when we're proving the lines are parallel. Okay, so now we have 2 is congruent to 3. I'm going to write down my other given. Angle 1 is congruent to angle 3. Given. So now look at 2 and 3. Michael, you with this? Okay, make sure your head's up and you're taking notes. Now look at 2 and 3 and see what we know from steps 2 and 3. 2 is congruent to 3, 3 is congruent to 1. What could we say now? Okay, so 2 is going to be congruent to 1, and they are all going to be congruent, but we had to work our way there. So number 4 could be 2 is congruent to 1, and why, Raina? Very good. Transitive property. They had 3 in common. We got rid of the 3, combined the other 2 parts. So transitive, and its property of what? Congruence. Okay, so now look at 2 and 1. What kind of angles are 2 and 1? Corresponding. And now that we know the corresponding angles are congruent, what does that tell us? That L is parallel to M. If the corresponding angles are congruent, then the lines that make those angles have to be parallel. And our goal is to prove the lines parallel. So number 5 would be L is parallel to M. What's the reason for number 5? Keep in mind, we're proving lines parallel. So we have to start with what? Converse of. Converse of, and then what kind of angles are they? Corresponding. So converse of the corresponding, and this keeps erasing, so please listen to what I'm writing, or what I'm saying. Corresponding angles postulate. Remember, this was the only one that was a postulate. The rest were theorems. Again, when do I know to write converse of? when you're proving lines parallel. So look at what your statement is and then ask yourself, am I proving the lines parallel? If so, then converse of. If I'm not, then it's just the original theorem. So then it's just up here, alternate exterior angles theorem. Questions? Okay, that's 3-3. We're going to shift gears to 3-4 now. Okay, 3-4 is going to have some easy parts and some more proofs. So I'm going to warn you about that. So on your notes, you may want to write this down. I'm going to list this up here on the board so that we can kind of get in our minds and be clear. To prove lines parallel, we have 5 ways we've learned right now. So I'm just kind of adding this to our notes. You can write it somewhere wherever you have room on the back or whatever. We have 5 ways. Yes, 3-4. So right now we have 5 ways. In 3-4, we're going to learn a 6th way. What do the 5 ways we've learned so far start with? Converse of. So all of these are going to be converse of, and then I'm just going to use little ditto marks all the way down through 5 just to save time. Converse of, and then we've got our 5 kinds of angles. Corresponding angles postulate, and then we have all of the other ones. Alternate interior angles theorem, alternate exterior angles theorem. Are you supposed to abbreviate? No, but I am because it's our notes. Please don't do that on your homework. Same side interior angles theorem and same side exterior. And all of these start with the 2 words converse of. There's 5 ways we've learned so far to prove lines parallel, and we're getting ready to learn a 6th and final way. So when you take your test over chapter 3, you're going to have 6 ways to prove lines parallel. Okay, so when you're thinking proofs and you're trying to get better at proofs and master proofs, you're going to have to memorize your 6 ways to prove them parallel. And then we're going to learn in 3-4 2 ways to prove lines perpendicular. But there's only 2 ways. And that'll be it, because remember, Friday is all about algebra. Are we good? Okay, so we're going to learn 3 new theorems in 3-4. 3-4 is not just proving, though. 3-4 is proving and applying, so you're going to have some problems that are not proofs, that are just simply writing some answers down, showing some work, doing some algebra. Okay? And that's where we're going to start. We're going to start with the part that's not proofs. I'm going to give you time. I think some people are still copying what's on the board, so I don't want to go too fast. I'm going to slow down in just a second. Okay, the first slide on your 3-4 notes is vocabulary. Heads up, also for those of you that are big planners, you like to know the plan, you like to know in advance, you have your study, you have a little planner you write it all down on. This class will have their vocab test next Tuesday and the chapter 3 test next Thursday. Okay, vocab next Tuesday, chapter 3 next Thursday. So it's going to be quick. All right, perpendicular bisector. We actually kind of talked about a perpendicular bisector back in chapter 1, but we didn't call it a perpendicular bisector. We just called it a bisector. Perpendicular bisector, first of all, what does perpendicular mean? They form a right angle. Two lines that form a right angle, right? Bisect means to do what? Okay, split. It does go through the middle, but what's the definition that we've tried to remember for bisect? Okay, it makes two congruent parts. So to bisect means to split into two congruent parts. So when you draw a perpendicular bisector, you're going to draw a line that makes a right angle because it's perpendicular, but it's going to go through the midpoint so that it bisects the segment into two congruent parts. So if you think about a line segment here, a perpendicular bisector goes through the midpoint so that it bisects, and it makes a right angle. And every bisector that we drew back in chapter 1 was a perpendicular bisector. It made a right angle. We just didn't talk about it as being perpendicular back in chapter 1. So our first construction is going to go back and review our construction from chapter 1 of how to bisect a line segment. Because to bisect a line segment creates a perpendicular bisector. Okay, second definition is this phrase, distance from a point to a line. When your book says the distance from a point to a line, you need to know how to draw that distance. So if I say the distance from me to the wall, would I go from me towards Max to get that distance? No, I want the shortest distance. So what would be the shortest distance from me to the wall? A straight line. And what will happen between this path and the wall if I connect those two? What will they create? A right angle. They'll be perpendicular. So when they say in a sentence the distance from a point to a line, they're talking about the shortest segment, which will be perpendicular every time. So when you draw that picture, you need to make sure you're drawing your distance perpendicular. If you draw it diagonally, that's not the shortest distance. That's longer. Does that make sense? Okay. So the shortest segment from a point to a line is the perpendicular segment. And this fact is used to define distance from a point to a line as the length of the perpendicular segment from the point to the line. So every single time you're going from the point to the line, making a perpendicular line segment. And that's what we're going to use for this very next example. It says name the shortest segment from point A to line BC. So you're looking at this picture. You're going from point A to line BC. Name the shortest segment. So what would be the shortest segment in that picture? AP. Everybody agree? AP is perpendicular to BC. AB and AC would be diagonal, and therefore they would be longer in length. Agreed? So when we name a segment, don't forget that we name a segment by putting a segment above it. So our answer would just be AP with a line segment above it. Pretty easy? Okay, because part of this 3-4 will be simple. The other part's proofs, and depending on how well you do with proofs, that'll either be easy or hard. So remind me, what kind of triangle is this red triangle I just created? A right triangle. And what do we know about AB? What is it? It's the hypotenuse. And what is always the longest side of a right triangle? The hypotenuse. So does it make sense as well that AB can't be the shortest distance because it's the hypotenuse of the triangle? Okay. So AP would be the shortest distance. So part B now wants us to do two things. It wants us to write and solve an inequality. So we're going to write an inequality and we're going to solve the inequality for x. So now we're back to Algebra 1. Remind me, what does an inequality have in it? Every inequality, what does it have in it? What makes it an inequality? What's different between an inequality and an equation? Equation has an equal sign. Okay, what do inequalities have? So what's in place of the equal sign? Greater than or less than. So there's going to be a greater than or a less than sign in an inequality. So anytime it says write an inequality, you need to be thinking I need a less than or a greater than symbol. They want you to write an inequality for x. So when you get to these on your homework, find x in the picture. Here's x minus 8. And then find another value in the picture, 12. And then you're going to write a comparison using a greater than or a less than symbol between those two values. So what do we know about x minus 8 since it's AC compared to 12, which is AP? It's greater, so our inequality would be x minus 8 is greater than 12. Pretty easy, right? Make sure you know how a greater than symbol looks compared to a less than symbol. Yes, the alligator eats the bigger one, so. All right, they said write, so make sure you write it, and then you're going to solve it, but this is part of your answer. Okay, how do we solve that inequality? Just add 8. Add 8 to both sides. If I add 8, I'm going to get x is greater than 20. And that's the solution. So write it, solve it. Don't make this too hard. Questions? Okay, the only other thing I want to remind you about is one of the rules you learned when you were solving inequalities in Algebra 1. Sometimes you had to flip your inequality symbol. When did you have to do that? When you multiply by a negative or divide by a negative. Has to be a negative though. So if you multiply or divide by a negative, you have to flip your inequality. Depending on how you write your inequality and how you solve it, you might end up with somewhere you have to multiply or divide by a negative. So be really careful about that on your homework. If you're just adding or subtracting, that does not affect it. Only if you're multiplying or dividing and only by a negative. Any questions? Okay, I only put one example in the notes, so I need to know if you have any questions about this. All right, so that's the easy part. Now we're going to look at the theorems and work some proofs. So first, I want to start with the parallel theorem. This one down here at the bottom that's going to show that lines are parallel, because that's where we left off with 3-3. We have 5 ways to prove lines parallel, and this is your 6th and final way to prove lines parallel. So if you want to flip over to the back of your notes or wherever you wrote these 5 down, you can add this 6th one. Here's the bad thing. It has no name. So bad or good, it means you have to write out basically what this theorem says. Doesn't have to be word for word, but it's got to contain the most important pieces. So let me explain it and then we'll write it over here on the board. It simply says if you have 2 coplanar lines that are perpendicular to the same line. So 2 coplanar lines are perpendicular to the same line. Look at the picture. That means I have R is perpendicular to T, and I have S is perpendicular to T. Does everybody agree that that's true by looking at the right angle boxes? So R and S are 2 lines, and they are perpendicular to the same line. What's the same line in this case? T. So somewhere in your proof, you would have to have R is perpendicular to T, S is perpendicular to T, and if that's true, then you could say that these 2 lines are parallel to each other. That's the last and final way to prove lines parallel. So, ouch. Let's write that down here. If 2 lines are perpendicular to the same line, they are parallel. That's what you need to somehow write down if you're using it in a proof. 2 lines perpendicular to the same line means the lines are parallel. You can use the way they wrote it here in parentheses if you like that better. But those are the key things you're looking for. Any questions on that one? Okay, last 2. Now we're going to prove lines perpendicular. And I want you to make sure you understand these theorems. I'm trying to go slow enough that you really are understanding what they're saying. So two ways we're going to have to prove that two lines are perpendicular. Again, this first one has no name. So we have to just know what it says. Okay? So I'm going to go through and pick out the important things. If two lines form a linear pair of congruent angles. So you're going to have a linear pair, and they're going to have to be congruent. Look at the picture. Do we have a linear pair up here in the picture? Angles 1 and 2 are forming a straight line, right? So in our proof, somewhere we would have to have written angle 1 and angle 2 are a linear pair. That would have to be listed in our proof. They have to be a linear pair, and what else do they have to be? Congruent. So they have to be congruent. So somewhere in your proof you would have to have angle 1 is congruent to angle 2. So two things have to be true. They have to be congruent and they have to be a linear pair. And if that is true, then the lines are perpendicular. So when I'm writing that down over here, trying to think of how to word that, I'm going to say if congruent angles form a linear pair, then the lines are perpendicular. That's a way you could shortcut it a little bit. If congruent angles form a linear pair, then the lines are perpendicular. Bless you. Or again, you can use their little way of abbreviating here as well. Questions before we go on to the last theorem of the day? Okay, last theorem is called the perpendicular transversal theorem. I'm going to go ahead and write it over here. Perpendicular transversal theorem. And I'm going to draw a little picture beside each of these just for when we get to these last two proofs today that you can kind of follow along. So this one is going to be a picture of congruent angles forming a linear pair. And here's the perpendicular transversal theorem. It says, and you can use the name on this one, you don't have to write it out in words. If a transversal, hence the name, is perpendicular, hence the name. If a transversal is perpendicular to one of two parallel lines. So if you look at the picture, you're going to have two things in your proof. N is perpendicular to Q. So we have the transversal perpendicular to one line, and N is parallel to P. The two lines are parallel. So if a transversal is perpendicular to two parallel lines, then the transversal will be perpendicular to the other line. So the transversal again was Q, so now we're saying Q will be perpendicular to the other line, P. So the two left over here, not in common, will now be perpendicular. Okay, so in my picture over here, I'm going to have two parallel lines and a transversal that's perpendicular to one of them. And then it'll be perpendicular to the other. Okay, I know you're getting tired. Two more proofs, and then we'll do something a little more physical where you're moving, okay? Some constructions. Okay, get with me to this page, and let's see if we can work through these last two proofs together. The more we do on proofs together, the easier they're going to be on the homework. And I know you probably get sick and tired of doing proofs, but I truly believe the more we do together, the better you're going to do. I should have given you a statement reason box, right? Okay. Okay, number one, first thing we always write down is what? Given. So we're going to write R is parallel to S. Given. I think there was one person who left their proof blank on the test and I wrote them a note. Are you kidding me? Really? So don't be that person. Never leave a proof blank. So R is parallel to S. I'm going to stop right there and let's see what that tells us. Go to your picture. R is parallel to S. Think about everything we've learned so far. What do we know if R is parallel to S? Okay, we know that 3 and 2 are corresponding no matter what, but what do we know about those corresponding angles if the lines are parallel? That they're congruent. So we could go ahead right now and say that 3 and 2 must be congruent. So angle 2 is congruent to angle 3. What tells us that? Corresponding angles postulate. Why is it not converse? We're not proving lines parallel, we're proving angles congruent. So you already know the lines are parallel. You're trying to prove the angles congruent. That's the original theorem or postulate. Corresponding angles postulate. Okay, now I'm going to write down the rest of my given. The rest of my given was 1 is congruent to 2. Given. For some reason, right through here on my smartboard, it always wants me to erase it. So make sure you have that down so you can look at your own paper because it keeps finishing away. So think about what we have here and tell me what could we conclude. Not yet. What are we saying back here? Angles 1 and 3 are congruent. We have 2 congruent to 3. We have 2 congruent to 1. So if 2 is congruent to both of them, that goes away. 1's congruent to 3. Good, and that's our transitive property of congruence. Hopefully we're using that enough. You're starting to see that well. If not, let me know and I'll try to explain it better. Transitive property of congruence. Now 1's congruent to 3. Go to the picture. Look at what we have. We have 1 is congruent to 3. We're trying to prove the lines are what? Oh, look at your proof. Perpendicular. So we have 2 options. We either need a pair of congruent angles that are forming a linear pair, or we need 2 lines to be parallel and the transversal needs to be perpendicular to one of them. Which one of these do we look like we have here? Okay, so Raina, you're saying perpendicular transversal. We do have a pair of parallel lines. Everybody agree? But do we have that the transversal is perpendicular to one of them? No. Okay, so we have this one. We have a pair of angles that are congruent. We just proved that 1 and 3 are congruent. And what kind of angles are 1 and 3? They're forming a linear pair. Everybody agree? Have we written that in our proof, though? No, you have to have in your proof that they form a linear pair. So we have to add that. I'm going to come up here, number 5, and we're going to put angle 1 and angle 3 are a linear pair. What tells me that they're a linear pair? Linear pair theorem actually says if they're a linear pair, then they're what? Then they are supplementary. What tells me that they're just a linear pair? Definition of linear pair. The definition says they're adjacent and they form a straight line. Do they look to be adjacent and forming a straight line? Yes, so that's the definition. Definition of linear pair. If you're not writing this down, you may struggle a little bit with proof, so I encourage you to be taking notes and write this down. So now we have 2 angles congruent, and we have that those same angles are a linear pair. So what can we say? 2 angles are congruent and form a linear pair, then what? And the lines are perpendicular. So which lines are we trying to prove perpendicular? R and T. So number 6 would be R is perpendicular to T. And the reason would be what we have over here on the board. There's not a name, so we're just going to have to write it out. If congruent angles form a linear pair, then the lines are perpendicular. And again, I just wrote what I had over here. So if it's hard to read on the board, read it up here on the whiteboard. Okay, we're going to do one more. I think the practice will help you. So look at the next one. And start trying to ask yourself, what are you trying to prove? Are you trying to prove lines parallel or lines perpendicular? So what does the last proof ask us to prove? Perpendicular. Okay, so this is what they want us to prove, right? They want us to prove these two lines perpendicular, so we're back over here. We've got two ways to do it. We either need a linear pair of congruent angles, or we need two lines parallel and the transversal perpendicular. So let's start looking at what's been given to us. Again, you already have this box, so I'm going to abbreviate, but don't abbreviate on your homework. So I'm going to start with my first given. Angle EHF is congruent to angle HFG. Again, I would remind you, if I were you, would draw my picture on my paper when I'm doing my homework, and I would mark my picture. They have already marked it for you. These two little arc marks are those angles that they just named. So stop right now and look at those angles. What kinds of angles are those two angles? Alternate interior. This would be the transversal, and this line here and this line here would be the two lines that are making those angles. Would you agree? If the alternate interior angles are congruent, then what does that mean about these two lines? That they're parallel. So we can state next that EH is parallel to FG. And these are lines, so we need arrows above them. So one was given. What's our reason for why those lines are going to be parallel? 6 ways to prove lines parallel. Which way did we just use? Okay, and what comes first? Converse of. So we're going to start with converse of, and then the type of angles. So they are alternate, interior, angles, and don't forget to put theorem. Okay, so now we have a pair of parallel lines. I'm going to mark those on my picture, that those lines are parallel. And I'm going to write my next given. So that was that FG was perpendicular to GH. Number 3, given. Okay, FG is perpendicular to GH. So look at the board over here. Do we have a linear pair of congruent angles, or do we have two parallel lines where one line is perpendicular to one of those parallel lines? The perpendicular transversal. Notice it said FG is perpendicular to GH. So here's this line. I've already drawn in the right angle box. It is perpendicular. So this line HG is perpendicular to FG, and FG is parallel to EH. So if FG is perpendicular to GH and FG is parallel to EH, this is the part that they have in common. Exactly. So if we have a pair of parallel lines and we have a line perpendicular to one of them, then that line, that transversal, is now perpendicular to the other one. So the two that were not in common, EH is now going to be perpendicular to GH. So EH now has to be perpendicular to GH. And the name of that theorem, one more time, is what? Perpendicular transversal theorem. Guys, you're going to have to spend a few minutes studying that so you can memorize the names and memorize what they say, or this will be a struggle. You have until next Thursday to really have it down, but you're going to need to spend a few minutes studying those postulates and theorems. Questions? Okay, Jump up, grab a compass and a straight edge.